Oh my! Look at these ones. They're so intricate and stylized. Man, they must have taken ages to perfect. I wish I could make something like this in just a touch of a button. I'm back! And smarter than ever. I took an intense IoT boot camp and was able to build lots of new skills, including programming, welding, laser cutting, and so much more. I also got to build upon my old skills, including a couple of years of 3D modeling. With all this new knowledge, I've done it. I created a fast and easy way to make fantastic art with just the click of a button. And today, I'm going to show you all how I did it. The goal is to find the change between two images. So naturally, it all begins by taking two pictures that are a little different, like the ones you see here. Now we can select a pixel. I think this area will do nicely. Now that we have our two pixels to compare, I've written up their RGB hex codes to give us a tangible value to work with. We could just subtract these numbers, but I had a different solution in mind. First, we have to split the hex code into its separate RGB values. That's 2 bytes or characters, in case you didn't know. Looks great, but this isn't what the numbers actually look like. They actually have hidden zeros, which I can show you here. As you can see, the numbers became all weird. We're going to have to make sure everything is on the far right in order to keep them truly separate. We can do this by bit shifting, pushing the information to the right, similar to putting it in the ones or tens place. There we go. Now our numbers are actually separate. The next step is to figure out which red from the two pixels is greater, and then the same for green and blue. Looking here, I can see that it will be the first red, second green, and second blue. Now we can find the difference between these values, placing the larger numbers in the menu end, or left side. I did the math already, and here you can see our new results. These will be used to create our new pixel. Here, I'm just smashing them back into a single hex code by using bit shifting once again. Here's what the color will look like. And there you go. Now we just have to do this again 173,160 times, and we'll have a new image. It'll be beautiful. Just kidding. We'll have a program do this for us in a matter of seconds. You might be wondering, why did the pixel end up so dark even though the colors were both bright? Well, lucky for you, I've got an answer. First, let me tell you that black is a simple value of 0. So the closer you are to 0, the darker the color will be. If you didn't catch it, I converted the previous hex codes to decimal form to hopefully give a little more clarity. If we subtract these numbers, we get a value of 2,554,086. You might think this is the same value as the new pixel we made earlier, but you'd be mistaken. It actually looks like this. Let me show you a special case I discovered with a different pixel. This time, our second pixel is darker. If we repeat the subtraction again, our new number is a higher value, or farther from 0, so this should be a brighter color. As you can see though, it's darker than the one we got before. But wait, it's actually brighter than the first pixel with the method I walked you through. If you didn't catch it, the second pixel didn't change, and we didn't do my special method. So why is it the same color? Remember the slide where we found which side was greater? Well, this peculiar pixel looks like this. The first picture has the high value every time, so the order when we subtract doesn't change, meaning our pixel is the same with either method. That's the end of my explanation. Thank you for listening. See you in 2 seconds.